Hello viewers, welcome to Elimu TV where you watch and learn. I'm your tutor, Alex Musawa, and I'll be taking you through Physics Form 3, lesson number 27. Our title is Motion Under Gravity. Welcome. What are the objectives of the lesson? Number 1, to deduce the difference between the acceleration of bodies moving on a land and when falling freely under gravity. Next we have, as you can see, what is gravity? We know that all objects are attracted towards the center of the earth. That is the law of gravity. Objects are attracted towards the center of the earth, and objects tend to fall down because they have weight, and weight is as a result of gravity. So let's, for example, you have an object and you throw it upwards. What will happen? It will come back down. That means there is a force that tends to attract objects downwards, and that is the force of gravity. And we have equations of gravity. In free fall, we throw an object upwards, from upwards to downwards. The object is falling freely. We assume that there is no frictional force between the object and the air. Therefore, we are going to use the equations of linear motion in this case, but because the acceleration is due to gravity, the A changes to G. Therefore, the first equation is V is equals to U plus GT. The second one, S, which is displacement, is equals to UT plus a half GT squared, where U is the initial velocity, G is the gravity, and S is the displacement. The third equation is V squared is equals to U squared plus 2GS, where V is the final velocity and S is the displacement. Next, we have free fall graphs. As you can see from the graph, we have the displacement time graph. We have the displacement time graph. That is for a body that is moving with varying velocity. You can see the curved graph that goes, the one that is downward there, next to the speed time graph. As you can see, that body is moving with a varying velocity, and the other one is moving at a constant acceleration. Next, we have horizontal projection. And what is horizontal projection? Horizontal projection is whereby an object is thrown horizontally. When an object is thrown horizontally, we assume that the object is following a curved path as it goes downwards. So let's, for example, you have an object and you throw it at a horizontal. What will happen to the object? Taking S, which is the displacement, which is equals to UT plus a half AT. U is equals to U and A is 0. Therefore, we are going to have the range. As you can see there, the range, the distance between O and X, and the range is equals to UT. That's how you find the range. Range is equals to UT. And H, which is the height from which the person is throwing the ball, the distance taken for the ball to fall from the person to the ground, that height, as you can see, from A to the ground down there, is a half GT squared. We have vertical projection, and that is when an object is thrown vertically upwards. That object moves against gravity, and therefore the equations are going to change, and it's going to be V is equal to UT minus V is equal to U minus GT. Next, S will be UT minus a half GT squared. That is for vertical projection. And V squared will be U squared plus minus 2GS. And that is the end of our lesson. I have an activity for you. Number 1. What is the difference between free fall, vertical projection and horizontal projection. Number 2, sketch a graph of a body moving vertically upwards. Our reference comes from KLB Book 3, 5th edition, Physics 2019. For more information, contact us on our phone number, YouTube Elimu TV, Facebook Elimu TV, Twitter at Elimu TV_KE. Thank you for watching Elimu TV. Stay tuned.